Well, now we have a system of equations, two of them. So let's deal with the first one. And we're supposed to solve this by substitution. So we've got 5x minus y equals 1 and 3x plus 2y equals 24. So let's take this first equation and isolate y. So we have 5x minus y equals 1. Now if we add y to both sides and subtract 1 from both sides, we'll have 5x minus 1 equals y. Well, we have y isolated. Now we'll go into the second equation, and for y, right here, we'll substitute 5x minus 1. In doing that, we'll be down to one equation, one unknown, and we can solve that. So here we go. 3x plus 2, in place of y, we are going to install 5x minus 1, and that equals 24. One equation, one unknown, we can solve that. So 3x plus, and multiplying through by 2, 10x minus 2 equals 24. So now we'll gather up like terms, and we have 13x minus 2 equals 24. Now add 2 to both sides, so we get 13x, and 2 minus 2 is 0, equals, and 2 plus 24 is 26. Now we'll divide both sides by 13, and 13's divide out here, and we get x equals 13 goes into 26 2 times. So now we know what x is. And we also know that y equals 5x minus 1. So in place of x, we'll substitute 2. So y equals 5 times 2 minus 1. So y equals 5 times 2 is 10. And there's our negative 1. So y equals 9. That means the ordered pair that will solve this system, the point where these two lines, if you were to graph them, will cross, is at the point 2, 9. Just to verify that, let's replace x with 2 and y with 9. 5 times 2 is 10, minus 9 is 1. It works there. 3 times 2 is 6. 2 times 9 is 18, 6 and 18 is 24. Hey, we did it right. Well, for our second system, we have to solve 5x plus 2y equals 3, and 7x minus 6y equals 13. We've got to do this by elimination. Now keep in mind, if we were to graph these two, they're both lines, and they're going to intersect at a point. When we solve the system, we find that point of intersection. So, what we'll do, if we only had a 6y here, then if we were to add these two equations together, the y's would drop out. So, to get a 6y here, we'll multiply this entire equation by 3. So we have 3 times 5x plus 2y, 2y equals, and 3 times 3. So we have to multiply every term by 3. And we get 15x plus 6y equals 9. Now, with that done, we'll take the second equation and we'll add it to this. So we get 7x minus 6y equals 13. Now we'll add those up. And notice the y's drop out, but we do get 22x equals, and 13 plus 9 is 22, so therefore if we divide through by 22, we'll arrive at the value of x, which equals 1. Okay, we found our x-coordinate. Now let's look for our y-coordinate. So I'll just take this second equation. It doesn't matter which equation we use, but I'll take the second one and substitute. In place of x, I'll substitute 1. So 7 times 1 minus 6y equals 13. That is 7 minus 6y equals 13. Now we'll subtract 7 from both sides, so we have minus 6y, 7 minus 7, 0. And 13 minus 7 is 6. Now we'll divide both sides by negative 6. These divide out, and we get y equals negative 1. So then we claim that the ordered pair where these two lines intersect is at 1, negative 1. Just to be sure, let's check it out by substituting 1 and negative 1 in for the appropriate in the appropriate places. So 5 times 1 is 5, minus 2, 2 times negative 1 is minus 2, does equal 3. 7 times 1 is 7, and a minus times a minus 6 is 6, and 7 and 6 is 13. So we did it right.